Let us discuss about the benzene diazonium chloride. Now this benzene diazonium chloride is a very versatile reagent in organic chemistry. And starting with this benzene diazonium chloride, you can prepare any functional group on the benzene ring. And this benzene diazonium chloride is obtained by reacting the aniline with sodium nitrite and hydrochloric acid in ice cold solution, 0 to 4 degrees Celsius, or you can write ice cold solution, and it gives a diazonium salt. This is called benzene diazonium chloride or benzene diazonium salt, and the side products are NaCl plus water. Now this preparation of a diazonium salt, this preparation of benzene diazonium chloride is known as diazotization. This is called diazotization, and the diazonium salt is obtained only when you have a NH2 group directly bonded to the benzene ring. Now what other groups are attached to the benzene, they just present as it is in the final product. So nothing happens to the other functional groups, and it is a reaction only when you have a NH2 group directly bonded to the benzene ring. Now once this diazonium salt is obtained, it undergoes two different types of reactions, and the first one is called substitution reactions. Now in these reactions we replace the diazonium group N2 plus by some other group of your choice. It can be any group G. Second type of reactions are called the coupling reactions. Which involves the retention of the diazonium group. Retention of N2 plus group. So in this case there will be no liberation of nitrogen gas, while in the substitution reactions the N2 gas is evolved, which is colorless and odorless. Now first we will discuss about the substitution reactions. Now this is benzene diazonium chloride, and the reactions of benzene diazonium chloride means the reactions of the aniline. So in one step you can change the aniline into a benzene diazonium chloride, and once this benzene diazonium chloride is obtained, you can change this into any functional group of your choice. This is a reaction of a diazonium chloride. Now for example, if you want to convert this into chlorobenzene or bromobenzene, like this is X, where X stands for chlorine and bromine, we use cuprous halide, Cu2X2. This reaction is known as the Sandmeyer reaction. So I can convert aniline into chlorobenzene, aniline into bromobenzene via these two steps. But we can also convert the benzene diazonium chloride again into chlorobenzene and bromobenzene using copper powder and HX. Again, X can be chlorine and bromine. Now you have a choice, either use Sandmeyer reaction or the second reaction with copper powder and HX, which is known as the Gattermann reaction. Now we can also convert this into iodobenzene using Ki. So it gives iodobenzene. So we can convert aniline into iodobenzene via these two steps. And we can also prepare fluorobenzene. In fact, this is the only method in your syllabus to prepare fluorobenzene using HbF4. It gives another diazonium salt which is bulky and is unstable, and on heating it decomposes to give a fluorobenzene. So this is another conversion, convert aniline into fluorobenzene, and this diazonium salt N2 plus BF4 minus on heating with copper and NaNO2 gives a nitrobenzene. So we can also convert aniline into nitrobenzene via this method. The next is we can also convert this into a cyno group using the CuCN. It gives a cyanobenzene, and once you have a cyanobenzene, it means you can add one carbon on the benzene ring, and this CN group on hydrolysis with the dilute sulfuric acid gives carboxylic acid. So we can convert aniline into benzoic acid, and via this method we can add one carbon on the benzene ring. And the same cyanobenzene on reduction with SnCl2 and hydrochloric acid and hydrolysis gives a benzaldehyde. So we are using a Stephen's reaction to convert the cyanobenzene into benzaldehyde. Now the next is we can also remove this diazonium group from the benzene ring by using a reduction using H3PO2, which is called hypophosphorus acid, or we can use ethyl alcohol. So via this method we can remove NH2 group from the benzene ring. This is called deamination. Deamination means removal of amino group, and once this benzene is obtained, we can change this into an aromatic ketone using a Friedel-Crafts acylation. Now this is aromatic ketone. And we can also prepare alkyl benzene using Friedel-Crafts alkylation, anhydrous AlCl3, it gives an alkyl benzene. So point is this NH2 group on the benzene can be changed into any functional group of your choice via diazonium salt. Now we'll discuss one or two questions how to use this flow chart of diazonium salt. Now we have a question that convert aniline into 1,3,5 tribromobenzene. Suppose we have this question, this conversion. Now our starting compound is aniline, and our aim is to prepare 1,3,5 tribromobenzene. So if you look at these two compounds, we have to add 3 bromines to the benzene ring. At the same time, we have to remove NH2 group. So first we perform the bromination because we have to introduce 3 bromines, so we need some strongly activating group. NH2 group is strongly activating, so we perform the bromination first using bromine in water in aqueous medium. So it gives a tribromoaniline, 2,46 tribromoaniline. Now once this is obtained, the next step is how to remove this NH2 group. Now NH2 group can be removed via diazonium salt. So we convert this into a diazonium salt in ice cold solution. So it gives 2,4,6 tribromo benzene diazonium chloride, which on reduction with H3PO2, this diazonium group can be replaced by hydrogen. So this is called 1,3,5 tribromobenzene. Now the second category of reaction is the reactions in which we retain the diazonium group. We retain diazonium group. These reactions are called coupling reactions. And these reactions are electrophilic substitution reactions in which we react this diazonium chloride, and this diazonium group is an electrophile. And this electrophile attracts at the electron rich carbon. So we are using an aromatic compound containing a strongly activating group G. So G stands for a strongly activating group. It may be NH2, maybe NHR, maybe NR2, OH, or it can be OR. Now all these groups are orthopara directing, but for this bulky electrophile to attack, the para position is more favorable. So we remove H from the para position, and it gives a azo compounds in which we retain the diazonium group, and these are called azodies. These reactions are called coupling reactions. Now let us discuss one or two questions. The first question is this: you have to write the structure of A in the following question. Now this is a reaction given. It's a benzene diazonium chloride reacts with anisole. So first of all, we should know what is anisole. Now anisole is a methoxybenzene, and methoxy group is a strongly activating group. So the coupling reaction will take place and results in the formation of this azodie. So you write the reaction in your rough work. Once you know this is my final product, then you write this final product as A. So our answer A is this. This is called para-methoxyazobenzene. Para-methoxyazobenzene. Now we discuss one more question. This is again a conversion that convert metatoluidine into metanitrotoluene. Now this is metatoluidine. Methyl anilines are called toluidine, and our aim is to prepare metanitrotoluene. So if you look at these two compounds, our aim is to convert NH2 group into NO2, and we can convert NH2 group into NO2 via benzene diazonium chloride like this. So the first step is diazodization. It gives a benzene diazonium chloride. Then we convert into another diazonium salt using HbF4. And then we use a copper in the presence of NaNO2. It gives a metanitrotoluene. So these are some reactions of the benzene diazonium chloride, and is a very versatile reagent in organic chemistry. Via this you can add any group on the benzene nucleus.